Hello, guys. So, welcome to your third lesson. Before we get started, just a reminder that you have the ability to print out this PowerPoint or reference this PowerPoint and anything that goes with it. So, by all means, please use it. Feel free to annotate on it. Call me out if I make any mistakes, maybe through email or Flipgrid or the discussion board. So what we're going to be starting with is where we left off with the last lesson. We were started talking about solving logs, and we had logs on both sides, logs on one side, and we looked at some complicated ones as well, right? Some challenging ones. So we're going to solve these for x. I'm not going to use a calculator because we have not talked about calculators at this point yet. So what we are going to be doing is using some of the properties. So look, I have the same base. I only have logs on one side. These both have a base of 2. So I can multiply their arguments. Log base 2. Not sure what's going on with the pen these days. It's just like being at school. Log base 2 of, what is that? X squared, right? Because x times x minus 3x. Equals 3. And then I'm going to use, this is the exponent that turns 2 into x squared minus 3x is 3, right? So 2 cubed equals to x squared minus 3x. Which then allows me to say this is 8 equals x cubed minus 3x. Oh no, that's x squared. So I've got x squared minus 3x minus 8. And is that factorable? What is going on with this pen? Nope, not factorable, right? So that means we have to use the quadratic formula. So -3 plus or minus the square root of b squared, so 9 minus 4 times 1 times -8, all over 2. Right, so if we go ahead to try to simplify this, we keep switching pens. You've got -3 plus or minus the square root of, what is this? 9 plus 32, which is 41, divided by 2. So it gives us 2 solutions. 41 is not a perfect square. But are they both valid solutions, right? Keep in mind that A, the argument has to be greater than 0. So are these both acceptable? Well, no, right? My argument has to be greater than 0. So the only thing x can be for this is -3 plus the square root of 41 divided by 2. It can't be the negative version. So let's go ahead over here to the second one, number 2, which looks really similar. So you've got ln, which ln is the same thing as log base e. Right, so again though, they have the same base, so I can multiply their arguments. So you've got ln of x squared minus 3x equals 3. So you've got e to the third power equals x squared minus 3x. E to the third power is not a nice number, right? Keep in mind e is not rational, so if I do e to the third, it's not rational. So I'm just going to leave it, and then I'm going to go about it in the same exact process I went about the other one. So 0 equals x squared minus 3x minus e to the third. And then I'm going to do the quadratic formula. So x is going to equal to -3 plus or minus the square root of b squared, so 9 minus 4 times A times C, which is negative e to the third. And the whole thing is going to be over 2. I'm not going to worry about simplifying that too much. I'm not going to be able to simplify that nearly as much as I would simplify it if that was a nice number. So I'm going to actually just leave the answer. I know it's only the positive version because we just did this problem. So we're going to get negative 3. Man, this is a little frustrating, guys. Plus the square root of 9 plus 4e, right? Plus 4e cubed all over 2. That's a 2, right? So that will be my answer to this. Maybe my computer needs a break. I'm doing too much with it. All right, so this was what we had done before. So I want to start with this and just make sure that we can solve these different types of equations that lead up to this point. What our focus in this, after we've done that, what our focus will be is actually just using a calculator to solve these, right? We really haven't incorporated the use of any technology. I sent out a link, and I'm happy to provide it again if you don't have access to it, but I provided a link to download a calculator. I have that on my computer, so I will show you kind of what it looks like. But especially if you don't have a graphing calculator at home, like Desmos is great, but it doesn't necessarily provide you the same experience of working with an actual graphing calculator. Or if you have an app on your phone, feel free to use that. But I did send out a link to download as well. So in conjunction with the properties I've learned in order to solve exponential or logarithmic equations. So the 3 things that we want to make sure that we know before we get into this calculator stuff is, can we solve log equations with logs on both sides? Can we solve log equations with logs on one side? And then can we solve exponential equations using logs? So can we solve log equations with logs on both sides? So like this. So the log is on both sides. Remember, once you simplify it into a single log on both sides, you can ignore the log as long as they have the same base. What's the base here? Base 10. So they're both simplified, so their arguments must be equal. Right, so x squared minus x minus 30 has to equal to 0. Factor. X minus 6, x plus 5 equals 0. So you've got 6 and negative 5. Can it be them, right? Keep in mind the argument has to be greater than 0. If you plug in negative 5, you get 25 minus 30, which is negative, so it can't be this. So your value of x is just 6. All right, 36 minus 30 is 6, and that would be a 6 as well. Let's look at another one. So here we've got to simplify first. So ln of, we can multiply the arguments because we're adding. Multiply arguments. So what is that going to be? 6x minus 18 equals ln of 3x So then we've got 6x minus 18 equals 3x. I'll subtract 6x, and you got negative 18 equals negative 3x. Divide by negative 3, and we've got x equals 6. Does that make sense? If x is 6, this would be 18. This would be 3, and then you multiply them and get 18. So yeah, that works. Cool. Right? So that's simplifying with logs on both sides. What about logs on one side? So something like this. It's a little bit more similar to the warm-up. So there's a few ways I could bring this up. I'm going to choose to multiply by 3. And then I've got ln of x equals 3. Well, that's the same thing as the log base e of x equals 3. The exponent that turns e into x is 3. So e to the third power equals x. And that is how I'm going to leave it. Ooh, look at this one. So here we want to combine these first. Logs on one side. So they're the same base. So log base 2 of x squared minus 3x equals 2. So change this. The exponent that turns 2 into x squared minus 3x is 2. So 2 squared equals x squared minus 3x. That's 4, isn't it? So 0 equals x squared minus 3x minus 4. Is that factorable? Sweet, it is. X minus 4. X plus 1 equals 0. So you got that x is 4 and x is negative 1. If it's negative 1, though, that makes this argument, right? Because the argument has to be greater than 0. So that doesn't work then. So your answer is that x equals 4. So solving with logs on both sides, solving with logs on one side. Now we're going to look at solving exponential equations using logs, right? So where we left off before, and I've said this, but like where we left off beforehand, before we went on break, was solving. We didn't know about logs yet, right? So we would solve this and change them so they have the same base and then use that ignore property. Here we're going to need to use logs, so we're not going to be able to get the same base. So I'm going to add 7, and that's going to give us 4 times 7 to the power of x plus 3 equals 12. Right, so that was, I added 7. And then I'm going to divide by 4. 7 to the power of x plus 3 equals 3. Right, so now let's change it. Log base 7 of 3 equals x plus 3. Minus 3, minus 3, so you end up with log base 7 of 3 minus 3. You can't actually subtract that 3. Right, so maybe make it clear, or you can even write a negative 3 in front and do negative 3 plus log base 7 of 3 to make it even clearer so that it's not looking like that idea. But you want to make sure that the argument's just 3. Like log base 7 of 3 is going to happen, and then you're going to subtract 3. That will be your last step. I don't care about an actual numerical answer, a rounded answer at this point. I just want the exact. What about this one? So right away, we got to change it to a log, right? So the exponent that turns 6 into 20 is 3m plus 2. Let's isolate that m. Minus 2, subtract 2 on both sides. Log base 6 of 20 minus 2. I'm going to put the negative 2 in front. Equals 3m, and then our last step is going to be to divide by 3. I'm having a lot of pen issues right now. It's literally no different than when we're in class. So we get for m, negative 2 plus log base 6 of 20. Make sure it's clear that that's the base. And the whole thing is divided by 3. If you want to have it multiplied by 1/3, that's fine. If you want to say negative 2/3 plus 1/3 log base 6 of 20, that's fine. If you want to do the negative 2 or the minus 2 after, I would just make sure that you are clear on what the argument is, that you maybe have it in parentheses. right? So we just did logs on both sides, logs on one side, and then solving exponents using logs before we even get to looking at calculators. Okay. Not every answer is going to be a nice number. So what do we do if we can't solve it by hand and like we need a rounded answer? So that's where the calculator is going to come in, and we really haven't picked them up at this point, or I don't think that we have. So we're going to be using our graphing calculator. I have one on my computer that I'm going to show you guys. So we want to, and I'm going to split my screen here. I'm going to have this up and my calculator. If I can find my calculator, there's my calculator. Let's see, is there also a way for me to write on this? Darn, I thought there was. It's okay. So I can still point. So what's going to happen here is we want to read the answer. So log, what is the exponent that turns 10 into 100? You know that one, right? That one's just going to give you 2. Is there an, I feel like there's an annotate usually. Where's the annotate function? What is this? I don't know. It doesn't want to give me one? No, it's okay. I'm over it. Can I draw? No. Can I review and ink it? No. Can I design? Isn't that going to be like some drawing tool? No. Smart art? No, it's okay. So what is the exponent? So you would know this one, right? However, that's one. If the base is 10, that's one you can put directly into the calculator. So if I just push log, oops, log of 100, enter, it's going to tell me 2. But I knew that, right? So that is a base of 10, right? This one's not going to be as nice. What is the exponent that turns 10 into 6? They don't have a common base, right? But I can use my calculator because the base is 10. So I can say log of 6. It's not going to be as nice, right? It's an irrational number. However, what I can do is, let's say I want to do that and I don't want to round to the end. I want to store this in my calculator. I've showed some of you guys this, but right here is a function. It says STO. I am going to store it, and you can store it as anything you want. I'm going to choose to store this as A. So I'm going to push alpha and math, which is the A. You see the A above there, and push enter. Now, anytime I recall alpha A, it is log of 6, right? So like that is what I store as log of 6. So what's very interesting is now I can do second log, which is 10 to the power of something, and then put that A in there. And what's going to happen? Oh my God, I get 6. Because it's like I'm taking the log of it, and then I'm doing 10 to that power, right? Because the outcome of a log is the exponent, right? That's why I got the outcome, I put it back in as the exponent, and it like undid the log for me, right? So just to kind of know how it's working or how you can even check your work. So what if you have this? This is, what is the exponent that turns 2 into 8? The exponent that turns 2 into 8 is 3. I wonder if we remember change of base. I'm kind of going off a little bit, but there is a way to put this into your calculator, right? So I'm not going to change, like I want to know how you actually change this base. Remember, it's log of the argument over log of the base. So I could do log of the argument divided by log of the base. And you know what it should be. It should give us 3 because 2 to the third power is 8. Whoa. What if you didn't use log? What if you used ln, right? That's log base e. Log of 8 divided by ln of 2. I think I said log, but I meant to say ln. Whoa, that's also 3, right? Because when you use the change of base, it's equivalent, right? Log base 2 of 8 is log of 8 divided by log of 2, or is ln of 8 divided by ln of 2, right? So just an extension on that. Ln of 8 is not going to be a nice number for us, but if we do ln of 8, we get this. I'm going to store it. I'm going to store it over that one. You know what? I'll store it as b. Second apps is b. And now anytime I recall b, alpha b, I'm going to get that value. What is the base when you have ln? Oh, right here, it's e. So if I do second ln, and then I put in alpha b, what would you guess that I should get? 8, right? I took the log base e and it gave me the exponent, and then I did e to that exponent. I should get 8. It should take me back to where I started. Pretty cool. Let's evaluate these. And you know what? I'm going to make this big, and then we will do it in the calculator. So let's think about how we're going to put these into the calculator, and then you guys can put them into the calculator, and then we can talk about the answer. So here, I would enter log of 6 divided by log of 7. If you tried ln of 6 divided by ln of 7, that's great too, right? But your calculator, we don't know this off the top of our head, and the calculator does not have a base of 7. It has a base of 10 and a base of e. Some of yours might, but I still want you to know how to do this so that you understand how change of base works. Here, well, the exponent that turns 4 into 60, I don't know that. So let's use the change of base again. Log of 60 divided by log of 4. Or maybe you're doing log, oh, sorry, not that. Maybe you're doing ln of 60 divided by ln of 4. And I'll put these in a calculator in a moment so you can check your answers. Here, what are you going to do? Log of 39 divided by log of 6.2. What about here? Just enter it. Round it to the thousands place, so that's 3 decimals. I'm not going to be able to see this ink when I close it out because apparently I have an old version of PowerPoint, but it's okay. I still want to show you guys. So that first one, I'm going to do log of 6 divided by log of 7. So that should be your answer to number 1, should be 0.921. Second one, log of 60 divided by log of 4. The answer to this second one should be, here I can even write it. So for this one, you should have gotten 0.921. Oh, 921. For this second one, whoa, I don't know why that capitalized it. We should have gotten 2.95, what is that, 3. For the third one, log of 39 divided by log of 6.2. We should have gotten, whoa, look at that, 2.008. And then for the final one, ln of 6, I should have gotten 1.792. Right, so if I do e to the power of 1.792, I should get 6. If I do 6.2 to the power of 2.008, I should get about 39. If I do 4 to the power of 2.953, I should get about 60. If I do 7 to the power of 0.921, I should get 6. Oh, that makes sense. I'm raising it to an exponent that's smaller than 1. and it's getting smaller. That makes so much sense. Okay, so this is how we're going to be using a calculator. We're going to finish up with these few. So what about this? How do we simplify these? Do we need to go into our calculator? Are these ones we need a calculator for? No. I could multiply these out, right? Or I know this. What is this equivalent to? 3. What is this equivalent to? 2. Oh, the answer is just 5. Right? So think. Before you go right into being like, oh, now I know how to use a calculator, I need to use a calculator for everything, think logically through it and see, like, do you actually need it? Do you need to do change of base? Do you need to pull out your calculator? Don't forget the things that we have talked about. If you want to use the properties and say log base 2 of 32, fine, you're still going to get 5. Right? But maybe before you start working on a problem, think through, like, you have a bunch of tools. What are you going to use? Here, I actually think we did this one. Right? So I know this one, but I think I'm just going to combine, right? So I know that this is 1, but I don't know this one or this one because the base here is 10. So why don't we combine these? Let's do log of 50 times 10 divided by 5. That's going to be 2. So it's going to be log of 100. So that's log base 10 of 100. So the exponent that turns 10 into 100 is 2. What about here? Similar to the one above, right? I might as well, oh, look, that's 3. Oh, look, that's 2. Subtracting them, it's going to give us 1. Maybe you looked at this and you were like, well, I need to divide the arguments. And you just knew log base 2 of 2. Oh, the exponent that turns 2 into 2 is 1. What about here? Should we bring that 3 down? So many different ways we can do this one. Log base 3 times log base 2 of 4. The exponent that turns 2 into 4 is 2. So it's 3 times 2, which is just going to give us 6. Maybe you looked at this and you were like, huh, 4, that's 2 squared. So then you had log, oh no, come on, pen, finish up this lesson with me. Log base 2 of 2 squared, which would actually be 2 to the 6th, because you'd have 2 times 3. And then you were like, oh, I know that those undo each other. And then you just got 6. Or maybe you brought that 6 down in front and you were like, 6 times 1. You still get 6. Regardless of what you do, you're going to get that your answer is 6 there. Awesome. So what we just accomplished in this lesson is we took our first look at, like, how do we use the graphing technology. So we looked at storing, we looked at change of base, right? We continued to practice the properties while also solidifying our understanding of solving both exponential and logarithmic functions and a variety of them. When logs were on both sides, when they were on one side, when you had to use logs to help you solve exponents, when you're going to be using a calculator, when you might not need a calculator. So this was kind of just a lot of practice with that. If you've got questions, please let me know. I encourage you to try some of the practice that is available to you.